Assalamu alaikum wa rahmatullahi wa barakatuh. We will continue with the second question since it will need some time. This is why I stopped the previous video in order not to make the video is too long. The following, which is question number 34, the following times were recorded by the quarter mile and mile runners of a university track team. Times are in minutes. Quarter mile times 0.92, 0.93, 1.04, 0.9, 0.99. Mile times 4.52, 4.34, 4.60, 4.70, 4.50. After viewing this sample of running times, one of the coaches commented that the quarter miles turned in the more consistent time, which means that the first group will be more consistent, which means there is no dispersion. المستقر means in Arabic. Use the standard deviation and coefficient of variation to summarize the variability in the data. Thus, the use of the coefficient variation indicates that the coach's statement should be qualified. We will begin to calculate here solution. In order to calculate, we must make two tables or make one table for the two sets of data. But notice here that the number of the elements in each data must be equal. Here you will have 5 data and the mile team has also 5 elements. Begin to calculate, make the table n equal 1, 2, 3, 4, 5, and then close the table for total. Here, quarter mile, I will put the indication that QM and let it, you can put QM as XI and MT as YI in order not to make convention for you equal X. Here 0.92, 0.98, 1.04, 0.9, 90, 0.99. Here you will have what? XI square and YI MT, which is YI. I will write 4.52, 4.35, 4.60, and 4.70, 4.50. And you will have here YI square. Close the table. In order to calculate, we must make addition. 0.92 plus 0.98 plus 1.04 plus 0.90 plus 0.99. The total will be 4.83. The other column 4.52 plus 4.35 plus 4.60 plus 4.70 plus 4.50. It will be 22.67. Notice, in order to calculate xi square or summation xi square I from 1 up to 5, you must have 0.92 square plus 0.98 square plus 1.04. I do it for one time. Since in the previous example I didn't discuss it, I do it by a calculator, but you must do it like this. 0.990 square plus 0.99 square. It will be like this. 0.92 square plus 0.92 square. It will be 0.8464. 0.98 square, it will be 0.9604. 1.04 square, it will be 1.0816. 0.9 square, it will be 0.810. 0.99 square, it will be 0.9801. Make the addition. You will have here 0.810 plus 1.0816 plus 0.9604 plus 0.8464. The addition will be the total 4.6785. Here 4.6785. You will do it the same for the second data. 4.52 squared, it will be 4 squared equal, it will be 20.4304. The second data point, 4.35 squared, it will be 18.9225. The third, 4.6 squared, it will be 21.16. 4.7 22.09. For 4.5 squared equal 20.25. Make addition for the total column. 22.09 plus 21.16 plus 18.9225 plus 20.4304. It will be the total 102.8529. Here I will erase the number here. Here I will erase it. You will have 102.8529. Here 8529. Now we will calculate x bar, which is summation I from 1 up to 5 xi over n. Over n will be 4.83 over 5. You will have 4.83 over 5. It will be 0.966. S square للX for the first sample, which is a Q or a quarter mile, عبارة عن I equal 1 up to 5 xi minus x bar whole square over n minus 1. You will have here, open it, I from 1 up to 5 xi square minus n x bar square divided by n minus 1. Here it will be summation xi square 4.6785 minus n5 multiplied by 0.966 whole square over 4. 5 minus 1, 4. I will make the calculation. 4.6785 minus 5 multiplied by 0.966 whole square. It will be 12 or 0.01272 divided by 4. The last answer will be 0.00318, which is very small. Sample deviation or standard deviation will be square root 4.00318. It will be 0.0563392 for which is x bar. We will calculate for the second group, which is mile times y bar equal I from 1 up to 5 yi over n, which is yi summation yi 22.67 22.67 divided by 5. You will have here 22.67 divided by 5. It will be 4.534. In order to calculate the sample variance for the group of mile times, you must write the formula s square y summation I from 1 up to 5 yi minus y bar whole square over n minus 1, which is summation I 1 up to 5 yi square minus ny bar square over n minus 1. You will have summation yi square 102.8 8529 minus 5 multiplied by 4.534 whole square over 4. I will make the calculation 102.8529 minus 5 multiplied by 4.534 whole square. It will be some number divided by 4. The last answer will be 0.01678. Sample standard deviation. Sample standard deviation will be square root of s square for y, the mile times, which means square root 0.01678. I will calculate it. It will be 0.129538. Now, in order to calculate, we must now calculate the coefficient of variation for each one. Coefficient of variation here, CV for x, it will be Sx over x bar multiplied by 100. It will be Sx 0.05, wait, 0.05, 6392. 0.056392 divided by x bar, which is 0.966, divided by 0.966 multiplied by 100. You will have it divided by 0.966 multiplied by 100. You will have here 5.8377%. This is the first coefficient of variation. Coefficient of variation for the second sample, it will be Sy over y bar multiplied by 100. It will be Sy here 0.129538 divided by y bar 4.534. 4.534. This is multiplied by 100. Here I will calculate it 0.129538 divided by 4.534 multiplied by 100. It will be 2.857%. Return back to the question. Now, after reviewing this sample of running times, one of the coaches commented that the quarter mile turns is in the more consistent times. In order to see the data is consistent or not, you must see the sample variance or sample standard deviation for both. Notice here, sample variance or sample standard deviation for a quarter mile, it will be 0.00318, and sample variance for the miles time, it will be point here. Notice here this box which is red, the other box also which is red. Compare between them. SX 3.00318. I will write it again now. S square X, it will be 0.00318. And S square Y, it will be 0.01678. I will write it here, 0.01678. The one with the greatest value, it will be, notice that SX square less than SXY square. Since 0.01678 greater than 0.00318. Then the data in mile times, in mile times is more variability or dispersion. And the data in quarter mile is more consistent. Is more consistent, and the coach that say it that the quarter mile is more consistent is correct. Consistent, and the coach is correct in his suggestion. Now, in his coach, now the another coach is correct in his suggestion, Now the another requirement in this question will be use the standard deviation and coefficient of variation to summarize the variability in the data. We finish from the standard deviation. Does the use of coefficient variation indicates that the Koch statement should be qualified? We will see the coefficient of variation. CV for X will be how much we calculated, 5.8377, 5.8377%, and CVY will be 2.85, 2.857, 7%. 2.857. Notice here, we notice here in calculating that the standard deviation for quarter mile is less than standard deviation of mile times. From the from the fraction here, you will notice here this number is less than this number, and also the sample mean, here is less than this. We notice as the coefficient of variation increased, it means that there is consistency between the data. We will notice that as CV of X increased, there will be more consistently more will be more stability and consistency between the data. And as the CV or coefficient of variation decreased, there will be more dispersion. Also, as coefficient of variation decreased, there will be more variability and dispersion between the data. And the coach words is correct that the quarter mile times the data of it will be more consistent time. Thank you very much and see you inshallah next video.